Git is a tool that keeps track of your project's files using a series of snapshots called commits. Although Git is most commonly used for software development projects, it's been used for collaboratively writing books and many other uses. In this video, I'm going to use flying logic to tell you, or rather show you, a simple story about how two people can remotely collaborate on a project using Git. Our story begins with me creating a new Git repository on my computer. I add some files to my new repository and make my first commit, A. Now I also have the default branch called master, which points to my commit. If commits are pages of a book, then you can think of branches as sort of like bookmarks. And I also have a pointer called head that indicates what commit I currently have checked out on my computer. So I change some files and make another commit, B. This commit records only the changes needed to make to A to get to B. B points back at A, which is why the arrow points to the left. A is said to be B's parent, and B is A's child. When I make a commit, my currently checked out branch, master, is updated to point to this new commit. This of course means head now points indirectly to the new commit B as well. So I add some files, change some others, and make another commit, C. Now I decide to push my repo up to a remote repository like GitHub. Now there are two copies of the entire history of the project. The remote copy of the repo also has its own master branch pointer, usually called origin/master. Unlike my local copy, the remote doesn't normally have a head pointer because nothing is checked out there. To make things clearer in the coming steps, I'm going to move the GitHub group out of the Wolf group. I still have all the commit history on my computer, but it's now also on GitHub. Now, another developer, Luna, clones a copy of this repo down from GitHub. She then has on her computer the same history as I do, including the master branch pointer. She has her own head pointer showing what's checked out on her computer. Now Luna makes some commits, D and E. Currently these commits are only on her computer. Meanwhile, I'm also working on the code, and I make some of my own commits, F and G. Now, Luna pushes her changes up to GitHub. This also causes the remote master branch to be updated. Luna's computer and the remote repo are now in sync, but my copy of the repo isn't in sync anymore, and now it gets more interesting. The remote master branch is now 2 commits ahead of my own master branch. If I try to push my master branch, the remote will refuse it, because that would mean stepping on Luna's changes. So, how do I share the changes I've made, and get the changes Luna has made without losing anything? One way is to do a merge. This involves making a new commit that combines the most recent commit on the remote repo with my most recent commit. This happens on my computer. There are 2 steps to this. The first one is fetch, where I copy all the recent changes down from the remote repo to my own computer. Fetching just makes the commits available. It doesn't actually change any of my working files or commit history. The second step is called a merge, where I create a new special kind of commit that combines 2 or more other commits. Both steps together, fetch, then merge, is called a pull, because I'm pulling all the recent changes into my own working copy of the repo. So here's the merge commit. It's added like any other commit on my computer. But it also points to the same commit pointed to by the origin/master branch on the remote. Whenever you merge, there's a chance that some of the changes you made will directly conflict with changes that you're trying to merge with. If this happens, the merge will not finish, and the files that Git can't merge will be put into a conflicted state. You'll need to decide how to resolve those changes to complete the merge, but that's a topic for another day. So let's assume my merge goes smoothly. Now I can push my commits, including the merge commit, up to the remote. As usual, this also updates the origin/master branch on the remote. Now, Luna's copy of the repo is behind the remote repo. Assuming she hasn't made any further changes, she doesn't actually have to create another merge commit. Her pull consists of a fetch to get the changes, and then simply adjusting her master branch to point to the latest commit. This is called a fast-forward merge. Now notice that in the middle of the history, it branches, with commits D and E being on one side of the branch, and commits F and G on the other. And then it merges, with commit H reconciling them. This is what we refer to as branching and merging. Finally, it's important to remind you that even though I'm showing each commit here only once in this Flying Logic document, as of this moment, every commit shown here is in all three copies of the repo: my own computer, Luna's computer, and GitHub. And since commits are identical no matter where they are, the commit A on my computer represents the exact same state of the project as the commit A on Luna's computer. This is the essence of the distributed development workflow that Git supports, and can scale to hundreds of developers working around the globe.